Hi, let's continue with our section, and in this video I want to talk about the supervised learning. So machine learning can be divided into many subcategories. Two broad categories are supervised and unsupervised learning. So these categories contain some of the most popular and widely used machine learning methods. So in this video and the next video, we will present them as well as some toy examples uses of supervised and unsupervised learning. So now let's talk about the supervised learning. So in examples such as those in the previous videos, the data consists of some features and a target. So no matter whether the target was quantitative, which is regressions, or categorical, which is classification. Under these circumstances, we call the dataset a label dataset. So when we try to produce a model from a label dataset in order to make predictions about unseen or future data, for example, to diagnose new tumor case, we make the use of supervised learning. So in simple cases, supervised learning models can be visualized as a line. So this line purpose is to either separate the data based on the target in classification or closely follow the data in a regression. So the data consists of some feature and a target. So no matter that the target was quantitative or categorical, we usually call the dataset a label dataset. So in the supervised learning model, we can build it visualize as a line. So you will see an example later. So this line purpose is to separate the data based on the target in classification or closely follow the data in the regression problem. So that is some of the important concepts that you need to remember. So now it is time to look at an example of that. So this is a simple regression model. So as you can see, there is a line here. So this line and a lot of points in here. So this is prediction, which is closely to the real data. So this is a simple relation with y equal to x minus 5 as the predictive model. So now it is a time to talk about it for a bit. So here y is a target and x is a dataset feature. So our model consists of the simple equation y equal to x minus 5. As is evident, the line closely follows the data in order to estimate the y value of a new unseen point. So we calculate its value using the formula, which is y equal to x minus 5. So let's look at the supervised learning with a classification problem. So this is an example. So we have the y and x, and also we have a line which is separate the test and the training data set. So this is a simple classification which y equal to x minus 5 as the boundary. So it's a time to explain it. So in the above figures, so a simple classification problem is depicted. Here the dataset features are x and y, while the dataset is the instance color. Again, the dotted line is y equal 5 to x minus 5. But this time we test whether the point is above or below the line. So if the point's y value is lower than the expected, which is the smaller, then we expect it to be orange. If it is higher, which is greater, we expect to be blue. So if the point y value is lower than the expected, we expect it to be orange, otherwise we expect it to be blue. And that is all in this video, so I hope you enjoy it, and we will talk about the unsupervised learning and also the dimensionality reduction in the next video, and I will see you in the next video.